Weather has played a pivotal role in many significant events in history, some of them disastrous. One such incident 35 years ago tomorrow vividly sticks with me. I remember exactly where I was when it happened, an event that shattered the stability of the manned U.S. Space Shuttle program. Now, the first orbital flight of the shuttle was in April 1981, when Columbia spent a little more than 2 days in orbit. By mid-January of 1986, another 23 missions had flown using Columbia and 3 other shuttles, Atlantis, Challenger, and Discovery. Weather had delayed many launches and landings in those years, but there were no catastrophic weather-related problems. One pesky design issue had dogged many of those early launches. To provide thrust, the shuttle used 2 solid rocket boosters connected to a large external fuel tank. Each booster had 6 sections, and some of the joints between sections were sealed by pairs of synthetic rubber gaskets called O-rings that helped contain the hot, high-pressure gases produced when the fuel burned. These O-rings had leaked during 15 shuttle flights prior to January 1986, despite redesign efforts to address the problem. In addition, low temperatures made the rubber O-rings less elastic and thus less likely to properly seal the joints. Now, the 10th flight of Shuttle Challenger was originally set for January 22, 1986. It was the highly publicized first teacher in space mission, but the launch was delayed until the 28th. That morning was unusually cold, with temperatures in the low 20s at Cape Canaveral. Shuttle launches were prohibited at temperatures below 31, so the launch was pushed back to late morning to allow the atmosphere to warm. But the unusual chill had already compromised the O-rings on one of the rocket boosters. Analysis of images after the accident showed gray smoke leaking from the booster in the seconds after ignition. At first, the damaged joint was temporarily sealed by residue from some of the burned fuel. But about 30 seconds after launch, the shuttle entered a zone of large wind shear, with speeds increasing from about 70 miles per hour at 20,000 feet to more than 140 miles an hour at 45,000 feet. In response, the automated steering system made more adjustments than on any previous flight to counter the changing aerodynamic forces on the vehicle. Were it not for this extra maneuvering, the temporary seal of the booster joint might have held, but instead, hot gas began to leak again and eventually flames that burned through the strut connecting the booster to the external fuel tank. That started a series of catastrophic events that led to the breakup of the orbiter 73 seconds into flight and the loss of the crew of 7. The Challenger disaster resulted in a 32-month hiatus in the Space Shuttle program. Once it resumed in September 1988, 110 more missions flew, including one other non-weather-related catastrophic failure, Columbia, in 2003. The final Space Shuttle mission was nearly 10 years ago, in July 2011. Stay tuned. Our extended forecast is next.